Platypus belong to a very small group of mammals called monotremes, which includes 4 echidna species and just the 1 platypus species. They are one of the only mammals that lay eggs, and their lineage stretches back almost 200 million years into the Mesozoic era, when monotremes first diverged from other mammals. What puzzles scientists is that monotremes have retained early amnio traits. They lay eggs, the shoulder and pelvis bone structures still resembles those of reptiles, and like birds and reptiles, they have a cloaca, a single opening for digestion, reproduction, and excretion. On top of that, their body temperature is lower than that of most mammals. The platypus averages about 32 degrees Celsius, compared to roughly 37 degrees in humans. But even with this lower temperature, they are not cold-blooded. Their body does not shift based on the environment. Scientists sometimes call the platypus primitive, but they do not mean less evolved. Rather, monotremes have kept many ancestral traits and even specialized them. Fossil records go back to around 123 million years ago with the discovery of Tenelophis tricellari in Australia, one of the oldest known monotreme relatives. These ancestors had teeth, unlike modern platypus, a duckbill-like snout, and skeletal structures more reptilian than mammalian. Platypus are egg-laying mammals, and the eggs that they lay are very similar to reptiles. Their eggs are soft-shelled, and female platypus typically lay around 2 to 3 eggs per clutch. They incubate their eggs for around 10 days, and like reptiles, they break out of the egg with an egg tooth. That is a fleshy nub that quickly sheds after hatching. Baby platypus are called puggles. They hatch extremely underdeveloped, similar to marsupial babies. They are tiny, described as being as small as a lima bean or a grape, and are hairless, pink, and blind. Female platypus do not have nipples and instead will feed their babies through skin patches on their bellies that secrete milk. Another crazy feature of the platypus is that it is one of very few mammals to possess venom. Only male platypus have this venom, and it is produced in their crow gland in their thigh before being delivered to a spur behind its back legs. Female platypus also are born with a version of this spur, but it regresses before adulthood. The venom is only activated through mating season, leading scientists to believe that it is only used by males in territory battles during fights for mates. One of the platypus' most advanced features is its electroreception. Platypus again are one of very few mammals with this ability. Their electroreceptors are modified mucus glands which are densely packed in their bills, allowing them to detect low-frequency energy waves such as muscle contractions and even heartbeats of small animals, similar to sharks, rays, and even some dolphins. When the platypus dives to hunt, it closes its eyes, ears, and nostrils by sealing them with folds of skin. This means that its primary senses are useless underwater. To make up for it, it combines another adaptation. Using densely packed push rods in its bill, it can detect physical pressure changes and movements. It combines this with its electroreceptors, and its brain processes this information to precisely pinpoint its meal. The platypus appearance is well known and widely talked about. Some say it looks like a combination of a beaver, duck, and an otter. It has sleek, dense, waterproof fur and is brownish in color like an otter. They have a duck-like bill and webbed feet similar to a duck in water. But unlike a duck, when they are on land, their webbing retracts to expose claws, more efficient for walking on land and digging burrows. Its furry, flat tail kinda resembles a beaver's, but unlike a beaver's scaly tail, the platypus tail is furry and doubles as a fat storage reserve. Mapping the DNA of the platypus did not help scientists understand this animal. Platypus have a mix of mammal, reptile, and bird genes. They have 10 sex chromosomes, whereas most mammals only have 2. At first, researchers thought the data was all wrong, but repeated tests confirmed it was not. Instead, it shows that monotremes sit in an intermediate state, retaining complex ancestral DNA even while branching off into their own lineage. While the native people of Australia knew about the platypus for tens of thousands of years before its introduction to Europe, the scientific discovery of the platypus was by a British man in 1799 when he received a platypus pelt and sketch from Australia. It was first believed to be a hoax. Scientists could not believe that the specimen was genuine due to how odd the platypus looked. After conducting some tests and dissections, it was deemed to be a real mammal and given the Latin name of this. The next step was to classify the platypus taxonomy, where naturalists ran into problems putting the platypus into any category. It was first classified as a mammal, but with caveats due to its conflicting traits. Modern science proves that monotremes are true mammals and shows how their ancient traits fit into evolutionary history. It proves the split 200 million years ago where the platypus fits into an evolutionary gap. Every feature of the platypus gives us insight into how mammals first evolved. Its unique genetics are not mistakes, but show how evolution works to specialize adaptations that work best for survival. Today, the platypus is vulnerable due to human-caused threats. Habitat destruction, unstable river flow, and pollution all put the platypus at risk. Losing it means losing a branch of mammalian history we can never replace. Protecting the platypus means protecting our evolutionary story. If you learned anything interesting about platypus today, please leave a comment down below. Drop a like if you enjoyed the video. Do not forget to subscribe, and I will see you in the next one.